hatch. You are go to open the hatch.
EV1 functional. EV2 functional.
Good afternoon. Thanks for joining us here at the NASA Johnson Space Center. I'm Gary Jordan from the NASA Public Affairs Office. Today, we are here to talk about a spacewalk coming up in 2 days to install new wireless antennas and some extra equipment to the International Space Station, part of some upgrades. The 2 space workers that are among the crew, were among the crew that just arrived to the station last Friday, launching with Oleg Artemyev of Roscosmos. Drew Feustel and Ricky Arnold of NASA will be our 2 spacewalkers heading out the door Thursday, March 29th for 6.5 hours of upgrades to the International Space Station. No worries about them getting used to their space legs. They're both experienced space travelers and spacewalkers. Drew Feustel actually has 6 spacewalks under his belt, totaling 42 hours and 18 minutes, split between 2 flights. His first 3 on STS-125, the 5th and final Hubble servicing mission of 2009, and then the next 3 on STS-124 in 2011, the mission that delivered the alpha magnetic spectrometer to the station, the device measuring cosmic rays and looking at the origin and structure of the universe. For Arnold, he has conducted 2 spacewalks totaling 12 hours and 34 minutes, both on STS-119 in 2009, that delivered the final set of the station's solar arrays. The spacewalk will be the 209th in support of assembly, maintenance, and upgrades to the International Space Station, the 7th for Feustel, and the 3rd for Arnold. So that's a little bit about the spacewalkers, but with me I have a panel of experts that are going to talk about the spacewalk actually coming up in 2 days, March 29th. Starting at my right, Kenny Todd, Operations Integration Manager for the International Space Station. Down the line we have Anthony Varia, Flight Director in Mission Control Houston. And finally, Grant Slusser, Lead EVA Officer for this spacewalk, EVA 49. So as usual, we'll start by going down the line for some initial remarks from our experts here, and then we'll open it up for questions first here in the room, and then on the phone bridge for those calling in, it's *1 to ask a question, *2 to withdraw the question if you realize it's already been answered. If you're following along on social media, we're following the hashtag AskNASA. Use that hashtag and we'll read them aloud here in the room for our experts. So with that, I'll stop and hand it over to our experts, starting with Mr. Kenny Todd. Kenny.
Hey, thanks, Gary. Well, good afternoon. It's great to be here with you again. Things continue to go very well on board the International Space Station. As Gary said this last Friday night, we were able to welcome Soyuz 54S on board the station, bringing Drew and Ricky and Oleg, and I'm happy to report that those guys are up and running and doing all the right things they need to do to be a part of the crew. Prior to their arrival, we had about a month of what we call an indirect handover, where Maker and Nemo and Anton were caretaking for the station and doing a lot of good work, a lot of good science, but I'm sure they appreciate the extra arms and legs. And in fact, we're off now into what I would call a very busy spring season for the International Space Station. The EVA, which we'll talk about here in the next few minutes, is going to happen this coming Thursday. Once we get done with the EVA, we're going to turn our sights to the arrival of SpaceX 14. The Dragon right now is poised and ready for launch on April the 2nd, this coming Monday. With an on-time launch, we'll see a berthing on Wednesday, the 4th of April. Our plan right now is to do about a 28-day mission. These Dragon flights are, I like to call them sprints, because they bring a lot of science. A lot of that science is duration limited. So when it gets on board, we're hot on it, and we go hard for up until the day of unberth. So anyway, they're fun missions, but they do take a lot of effort. So anyway, so we're gearing up for that, and as quick as we get done with this EVA, we'll turn our sights to that mission. Once we unberth the Dragon about the 2nd of May, then we'll start looking at our next commercial resupply vehicle, which will be an orbital ATK Cygnus module. And right now our thought is probably launch somewhere around the 20th of May, get there a few days later on the 24th. And our thinking right now is probably somewhere around a 60-day mission with the Cygnus. and at that point then we'll have it full of trash and we'll send it on its way, and it'll burn up in the atmosphere. So in terms of what's going to happen once the Cygnus gets there, it brings typically a fair amount of science, but a whole lot of consumables with it and spares. And so anyway, as we can over the next 60 days while it's there, we'll be unloading it. But in parallel with that, we've got our sights set on a couple of EVAs in this same time frame to go do some additional work. To basically move some pumps around that we have on station, get them in a better place for us to access them from a robotics standpoint. We also have some failed pumps that we're just trying to move to other places. So again, we can use the sites that we'd like to have for robotics capability. In addition to that, when you look at the commercial crew vehicles that'll be coming in here in the not too distant future, we're continuing to do upgrades as necessary to support those vehicles. And one of those is a set of cameras that we're going to put on board on the station on the node 2 forward area, so that as these commercial vehicles are approaching, that we can get some good high definition video of those approaches, and it just helps our controllers. It helps us all for situational awareness of how the flights are going. And so anyway, we're gonna put those on with one of these EVAs probably in the late May to early June timeframe. We're still trying to sort all that out. But anyway, so in the next couple of months here, we've got 3 EVAs on the books in addition to these 2 cargo vehicles. In the May timeframe, that's about the time we'll draw a close to this 6 crew timeframe that we're in right now, with Maker and Nemo and Anton returning about the 2nd or 3rd of June. So anyway, we're in a bit of a crunch right now with a lot going on, but again, these are really exciting times and a lot of good stuff going on board, and this partnership is continuing to excel at every turn. And so anyway, just a lot to look forward to over the next couple of months. As far as what's going to happen this week, this Thursday, as Gary said, we are going to do an EVA. We got 3 primary things. The guys to my right will give you a little bit more of the details, but at a high level, we need to install an antenna that allows us some wireless capability. That's going to allow one of our payloads that we have coming up here in a couple of months on SpaceX 15 to be able to acquire its data and do its job that it needs to do. So anyway, we are a little bit racing the clock trying to get this hardware out there. We've got time to go do this EVA, but we don't want to wait too much longer. We want to go ahead and get this hardware out there. In addition to that, as most of you know, back last year and for some time, we were chasing a bit of an ammonia leak on the port side, and we continued to get more and more data and get better refinements on exactly what might be going on. So we made the decision last year to isolate it at one of the radiators, thinking we might have come up with the potential leak scenario for where the ammonia was being liberated. And it looks like that there's a set of flex hose jumpers that we have it narrowed down to. And so based on the reef configurations that were done back last year and seeing that the leak stopped, we feel pretty comfortable in saying that the issue is with these jumpers. And so part of this EVA is going to be to go out and basically remove those jumpers, bring them home, give us a chance to do the analysis on them, try to understand the failure modes, and then make sure that we understand our risk going forward in that particular area. And then the third primary objective is to go and put a camera out in an area that's, we call it CP8, which is on the zenith side of station. The camera that we have there right now is not functioning properly, and so it doesn't give us your typical pan and tilt type of function that's required for our controllers and flight directors to be able to get the situational awareness that they need. And so we're going to go out and replace that camera, recover that capability to get that video. So anyway, those are the 3 primary objectives. If we have a little bit of time left over, as Anthony will tell you, we've got some get-aheads that we'll try to get along the way. But in general, that's the 3 primary things we're going to do with the EVA. As far as our readiness, this morning at the ISS Mission Management Team meeting, we looked at all the data. We looked at the suits. We looked at the environment that the crews are going to be operating in. Everything looks very good at this point. Very, very little open work left. So We took the poll. We were 100% unanimous that we're to go support the EVA this coming Thursday. So we're excited to go and get this EVA done and get it behind us. So with that, I'll turn it over to Anthony and let him talk to you a little bit about the details.
All right, thank you, Kenny. I'm Anthony Vari. I'm one of the flight directors here at the Johnson Space Center. I'm here on behalf of Tony Sacacci, who's going to be the lead flight director for this Thursday's US EVA 49. I'll be picking up as lead for EVAs 50 and 51, which Kenny alluded to as happening in the May or June timeframe. So those three main objectives that Kenny was talking about, the wireless antenna, the camera R&R, and the radiator jumper retrieval activities are what we're focused on for this EVA. Actually, if you can put up the first graphic, we've got some these wireless antennas already integrated into some handrails, and if you've ever done any home networking, you know that while your living room might get good Wi-Fi signal, maybe your front porch, the signal drops off. Well, the International Space Station has a front porch. It's called the GEM Exposed Facility. We do science on it, and we want to make sure that we've got good Wi-Fi coverage out on that facility so that some of those upcoming payloads that require that Wi-Fi to get their science to the ground have that resource available to them. So Drew Feustel, as the EV1 position, is going to go out to the end of the Node 3 module and attach the handrails with the antennae integrated, as you see in the graphic there. And let's see, next slide. So the next item that was alluded to is the RBVM, radiator beam valve module jumpers. There's two of these things because all the heat generated by crew and equipment in the International Space Station eventually works its way to the big radiators on the P1 and S1 truss. So we're looking at the P1 truss here. We've got several of these radiator flow paths, 6 to be exact, on each side of the vehicle, so 12 total. And as Kenny was talking about, we had an issue where we noticed a very small leak from one of those flow paths. We were able to isolate it, vent out all the ammonia, and now Ricky Arnold on the robotic arm on Thursday is going to go out to this work site and remove these two jumpers. One has some 1-inch connections on it, one has some 3/4-inch connections on it. And that's so we can bring them inside to the vehicle and eventually bring them back to Earth for failure analysis and potential replacement. Next slide. So the third activity that Kenny was talking about deals with the camera port on the port truss. This is right near the site of those radiator beam valve module jumpers. And this is a external television camera group, ETVCG is the terminology you'll hear there. And we've got both crew members working on this one, Drew on free float and Ricky on the arm. This camera is bigger than you think it is, so it is helpful to have two crew members out there. And so you can see there in the graphic, there's a light, there's a camera, that's a standard def camera, an HD camera, and that all sits on top of a pan-tilt assembly. That pan-tilt assembly right now neither pans nor tilts, and the SD camera isn't able to transmit signal to the ground right now. So we are going to replace that whole camera. We are going to keep the HD camera from the current structure, take it off of the old camera, if you will, put it onto the new camera, and hopefully we'll be able to see some good pictures from the new standard def camera by the end of the EVA. You know, we use these cameras not just for pretty pictures of the Earth, though they are good for that, but also for the aid in robotics, so we can see what we're doing with the arm on the external side of the vehicle, as well as visiting vehicle tracking and capture. So those are the three big activities we're taking care of on this EVA. We do have some scheduled time at the end of this EVA to perform some get-aheads for the next EVA, US EVA 50, and that's going to involve the jumper that I've got right in front of me here on the table. We've got this jumper out there on the S0 truss that's a legacy of the way the thermal system used to be operated. Before the Node 2 was there, this jumper was in place to short circuit one of the ammonia loops. Well, it doesn't really serve a purpose for us right now. Peggy Whitson stashed it in the S0 truss many years ago, about 2007. But we found some use for it where we can utilize that for the next EVA to act effectively as an accumulator, an expansion module for some ammonia equipment that we're going to be dealing with. We'll hear more about that as we get into EVA 50, which I hope to be briefing you guys on in about a month or two. So that's getting that jumper in place is a real help to the EVA 50 team, and we are certainly looking forward to getting that acquired. As far as the readiness of the team for this EVA this week, crew and the spacesuits are ready to go. We've been having conferences with the crew. They're excited to get out the door. The IV, the intravehicular crew, is ready to support them by moving around the robotic arm. And so everybody's looking forward to a great EVA on Thursday. And that's when Mr. Slusser over here is going to take over as our lead spacewalk officer. And he's going to walk you through exactly what we're going to be doing on Thursday. Grant?
All right, so thanks, Anthony. It's a great lead-in. Like you said, I'm Grant Slusser, lead of this EVA, along with my team, James Montalvo, Mitch Hargard, sorry for names, Costa Marvitas, and Michael Dino. So I did it again. They keep laughing at me for messing their names up. But we're going to lead this spacewalk. We've been doing it since October timeframe, getting all the procedures ready and up to date. And we're ready. We've been talking to the crew like Anthony spoke. And it seems like the whole team is getting ready, from the engineering community to the flight ops community. So I think I have a great video. We've been producing this over the last week. And if we can play that now, it'll walk us through our Doug review. We're going to start the EVA at the airlock with both crew coming outside. Once we get outside, we'll start with EV2, working over to the port truss where he's going to ingress the arm to get ready for the RBVM task, or radiator beam valve module jumper removal task. As he's doing that, EV1 is going to go aft port to node 3 in cone, where we're going to install some external wireless communication antennas. On a previous EVA, the handrails that we're replacing have been removed, and the new handrails that we have taking out aren't going to have the antennas installed for this wireless communication system outside. We're going to start on the nadir side, deploying a nadir antenna and a plate. It's going to replace the handrail that we had removed previously. Once we get that antenna installed, then we're going to move up to the zenith side, where we're going to install another on-orbit installable handrail with an antenna. After we get the two handrails installed with the antennas, and we're going to connect the two cables. Prior to the pressurized mating adapter being removed, we installed a cable in there to connect these two, and we're going to connect them underneath the PMA cover and then down to the nadir antenna. Once both antennas are installed and the cables are hooked up, then EV1 is going to go back to the airlock and change out bags with this bag to the large CP8 camera group bag that we're going to deploy. As a team, EV1 and EV2 will work together. While EV1 was working on the EWC antennas, EV2 has been steadily working to get the RBVM jumpers removed. We're going to start with the heater cable electrical connections. Once those are removed, then we're going to remove the clamps holding down the RBVM jumpers and remove both jumpers. And this is an indication of the RBVM side, or the radiator beam valve module side. After that, we're going to go to the radiator side of these jumpers and remove those. Once we have both jumpers removed, he's going to stow them on his bag configuration on the outside and prepare for the next task of the camera group. EV1 is going to go out to that same area EV2 is at, so he's going to go out to the port side of the truss where camera port 8 is zenith. It's going to prepare and deploy the bag with the new camera group and get ready for EV1 to translate over from the RBVM. You see here it's a short transfer over from the RBVM jumpers to the camera group. This is a camera port 8. The pan and tilt has stopped working, so we're going to pan and tilt that unit down into the stowed location before we remove it. So both crew will work together to get this camera group out. The first thing is moving it to the stowed location so we can remove it. After that, we'll lock the pan and tilt unit and disconnect the electrical cable. Once that's disconnected, then we'll position ourselves to remove the camera. We have an HD camera and a standard camera. We're going to reuse this high definition camera. So we'll remove that prior to removing the camera group. Once that's removed, then we'll remove the camera group, which is the camera and the light. And he'll hand it down to EV1, who will hand up the new camera group. While EV2 is working on the new camera group to get it installed, EV1 will be packing up the failed unit and taking it back to the airlock. As EV1's completing that translation back to the airlock and getting a get-ahead bag there, EV2 is going to continue with the camera install. We'll start with the standard camera and the light install. Once we're complete with that, then we'll work on the HD camera, putting the HD camera that we removed previously back on to the camera group. After installing the HD camera, we'll reconnect the electricals to get it all powered up, and we'll be complete with this task. EV1's back. We're going to transfer bags. If we have enough time, we're going to go after a couple of get-aheads while the crew is on the arm. EV1 is going to take back the jumper bag and put it in the airlock. For this video, we have not shown the get-ahead, so EV2 is going to get off the arm there at the port truss, and EV1 is going to go get ready for the next EVA. We're going to remove a jumper from behind the MLI on the starboard truss and take that down to the PFCS. For the next EVA, the PFCS relocate. They're going to be swapping out 2 pump flow control sub-assemblies. So we're going to help them and get a little bit ahead by removing this jumper and deploying it down at the PFCS on the port side of the lab. And then he's going to be complete for the day. EV2 is going to take the APFR out of the arm that he's been riding and take it to that same location again, trying to set the next EVA up to get a little bit ahead when they go out the door so they don't have to move these items down to the work area. So he's going to take it to the port side of the lab where he's going to deploy that down at the PFCS locations. Once we get that installed, then both crew are going to return to the airlock and come inside. All right, and that's a good overview of the EVA with the animation. Appreciate everybody for putting that together.
Fantastic. Thank you so much. All right, with that, we'll open it up for questions. We'll start here in the room, and then we'll open it up on the phone bridge. And then again, if you're calling in, it's *1 to ask a question, *2 to retract it if it's already been answered. And then if you're following on social media, it's the hashtag #AskNASA. So with that, we'll open it up for here in the room. If you could state your name and affiliation before the question, we'll get going.
Hi, Robert. Oh, thanks. Hi, Robert Perlman with CollectSpace.com with a couple of questions. First, I realize they're experienced spacewalkers. This is coming 6 days after arrival, though. Is there a minimum amount of time between an arrival or another activity like a visiting vehicle or crew that you would not do a spacewalk within that set amount of time?
Well, is there a minimum amount? At some point, we need to do what we need to do, right? If we find ourselves in a contingency situation, we've actually had a situation where we did a contingency spacewalk within a couple of days of a crew coming home. And we weighed all the risk associated with that. And again, that was a crew coming home. That particular crew member wasn't overly active in the Soyuz operation. So yeah, if we find ourselves in a situation for a crew coming home, we can do those kinds of trades. When it comes to the other side, when you talk about a new crew coming up, you have to remember that you know, when we were flying shuttles, that was a routine thing to have a crew come up, and within a day or two, you know, they were out the hatch. So it's all about the preparation when it comes to being comfortable in going out. Can we get done everything we need to get done before that crew gets there? In some instances, we had turned on a lot of this prep work before they even got here, got to station. And so these are experienced guys. They've done the shuttle model before, where you get on orbit and you go out pretty quick. We did lean on that a little bit here and use that to help convince ourselves that this was an okay thing to go do. So yeah, we looked at it pretty hard, and all the conditions are right to go ahead and do this in this first week. And so again, it's not new ground for us. We've done them this early before in an increment, and haven't seen any real issues with it. So but in terms of you know, is there a line somewhere in the sand? I think it's a case by case, Robert. I don't think we can say there's a ground rule or there's a way to approach that. You have to look at each situation differently and look at all the variables.
Okay.
I don't know
And
if you
follow
want
up
to say.
with regards to the camera replacement. Since you have an HD camera, is the SD camera just there for redundancy? Is that why you're replacing it, or why do you maintain a SD capability when you have HD now?
That's a good question. So the standard definition cameras, a lot of our systems are designed, particularly the robotic systems, are designed to route a standard definition camera. The wiring goes a little bit more into the guts of the space station as far as what everything was designed around. And so if you're working at the robotics workstation, those camera views that you're looking for when you're very easily dialing up cameras on that workstation are going to be the SD cameras. Crew can utilize the HD cameras. We can route it through a laptop that they can set up right next to the robotics workstation. But the SD is really the workhorse and allows us to get the clearance information and the high reliability that we need to do a lot of our operations.
Very cool. Okay. Again, if you're calling in, it's *1 to ask a question. With that, we'll hand it over to social media, see if we have a couple Ask NASA questions.
Yeah, from Instagram. How long does it take to put on the EVA suit?
I can take that one. It's actually about a 4-hour process to get out the door, but a lot of that's with pre-breathe. Crew member just getting in the suit will take about 20 to 25 minutes to don the suit and get it pressurized up.
From Twitter, how much time do you spend training for the spacewalk? And is the training focused on specific mission tasks or just general tasks?
A little bit of both. With this crew, we had the opportunity to look ahead at these next couple of EVAs while they were in the United States, and we got them some of the training. They received most of my EVA and partial on the next couple of EVAs. So we have some task-based training. So we try to do task-based if we know what crew's going to be on board and what time the EVA is. Otherwise, we do systems or specific training to just generic ORUs. So this crew has had a little bit of both. They get about an 18-month process to lead up to to getting on board, and that's about 9 EVA runs in the water, and not assuming that they have any extra, but 9 is their template.
One more from Instagram. Is it possible for someone to do an untethered spacewalk?
Possible, or we do not train untethered spacewalks. We do have a safer that could fly us back in an emergency in case we came untethered, but there is no option for a crew to go out and not tether. I mean, that's just against all protocols that we have.
Thank you. Okay, we'll go back to the room, see if there are more questions.
Hi, Robert Perlman with CollectSpace again. I believe this is going to be the 100th EVA from expedition crew members. So I wonder if you could take a big picture look at where we started back in 2000, approaching the I guess 18th anniversary of crewed activities, 20th for the space station, and if spacewalks are becoming more routine, if we're getting comfortable with, I guess comfortable is the wrong word, but more familiar with how to plan these so that they're not the exceptional activity that they were at the start.
Routine and spacewalks in general, I caution everyone against that. In fact, every time we do one of these readiness reviews to get ready to go do a spacewalk, I remind people it's probably the most dangerous thing we do in terms of on-orbit operations. And we have to remain very vigilant. It's probably one of the areas from a space station program standpoint, it's probably one of the areas where we've learned the most about how to not just go out and do EVAs, but how to take care of the suits on board. We've had some things happen that were a direct result of the way we were caring for these suits and having them on orbit and trying to do what we thought were the right things, and then the reality was that they were working against us. And so that's been a continual process of learning over a bunch of years. But you know, the routineness of it, I hope we never speak in terms of an EVA as being routine, because it's one of those things we all need to be right-minded when we go and evaluate it. We have to be on our toes when it comes to you know, checking all the boxes and making sure that we're committed to going and doing an EVA. So yes, we've done a lot of EVAs. Yes, we've had a lot of success with EVAs, but that comes with a lot of hard work and a lot of preparation and attention to detail. And I don't want us to ever forget the lessons that we've learned along the way here. And so you know, we have to constantly tell ourselves, don't let ourselves backslide here in terms of the way we view EVAs. The fact that we're doing a lot of them doesn't mean that it's a given you're going to be successful the next time around. We have to continue to pound everything flat and work the details and look each other in the eye and seriously say we're ready to go do this and it's worth going to do. Because again, it is something that I consider one of the most serious and critical things that we do.
Thank you. With that, I guess we'll go back to Ask NASA questions.
Okay. Again from Twitter, what kind of fabric is used to is the EVA suit made of to protect the astronauts?
EVA suit has about 7 different layers, from an ortho fabric that's got a Kevlar blend mesh in it, down through a Mylar layers. Depending on where it is in the suit, you could have up to 5 to 7 layers of Mylar, as well as a polyurethane and a couple of safety layers. So it's quite a bit of buildup. The least amount is in the top of the gloves because you need dexterity there, but the rest of the suit is pretty much about 7 layers from the outside ortho fabric down to the bladders.
Another one from Twitter, can an astronaut eat or drink during a spacewalk?
They have 32 ounces of water. That's all they get. And that's not just during the 6.5-hour spacewalk, but the 30 minutes after to get out of the suit, as well as the 2 hours before when they get into the suit. So they eat right before they get in, and they eat right after they get out. So,
if the astronaut loses something during a spacewalk, does NASA track the object?
I can take that one. So we have a trajectory officer in mission control that is going to be sitting there during the EVA, and we'll be watching for items like that. First thing we look at is video. We talked about the importance of video here. This is one of the things we use video for. We see what the trajectory of the item that's gone overboard is and where it might be heading. We get a rough feel for speed. We have a preconceived notion, at least we have some analysis on most equipment of what's the density, what's the drag, where do we think this thing is going to go. And from there we can propagate and see, well, is this thing going to come around and be a concern on the next orbit, or is it going to slowly kind of spiral away and not be of a concern? So if we see something released, that's when the trajectory officers really snap to it and are watching for that.
Very cool. More questions? We can continue to, again, hashtag Ask NASA if you're following along on social media. We're reading live questions, and we have a couple that we've collected from the past couple days, so we'll keep reading those. You don't have any? So I guess kind of going off of the suit, the fact that there are less in the fingers for dexterity, what are some of the challenges that astronauts have when conducting an EVA that they would need the extra dexterity?
Well, just that is all they have. So that is our main tool. We don't use our legs, we don't use our feet, we use our hands and arms. So as long as we can manipulate the arms and use the hands and make sure the gloves are fitting right, then that's our work platform for the whole day. That's our work area. So It's got to be there. It's got to have dexterity. You got to be able to feel your fingertips. On this EVA, we're actually hand starting a couple of bolts on one of the antennas to make sure that they don't cross threads. So we have to have that fine dexterity to be able to hand start those bolts.
Now, is there a reason for the CP8 camera that the astronauts are in the position that they are? I know one astronaut's going to be climbing up, but then the other one's going to be on the robotic arm, and from the animation, looked like he was going to be upside down.
Right, and upside down in space is not really a problem. There is no upside down, so he's just going to be on top of station looking back at station. But you're right, there's a stanchion that has a camera, and we have to avoid kick loads going up there because it is pivoted on the truss. So we want to make sure that no crew is climbing up and down that stanchion. EV1 will be there to help him out, kind of handing stuff on and off, but not really translating on that. So we've found from past experience it's better to do that in the arm and have the crew member in the arm actually replace the camera.
Very cool. So Anthony, from a FOD perspective, talking about these HD cameras that we're continuing to upgrade, this is a process of replacing and getting this HD capability. Talk about some of the best benefits that you can get from a flight controller perspective with the extra resolution.
Sure. HD, the quality on the video is useful to us in flying a spacecraft. As I said, it's not just pretty pictures. You can go zoom in on a piece of equipment that you might have some concern with and say, okay, well, what is the state of that equipment? The type of information you can't get from just looking at the many sensors and transducers that we have all across the station. Getting a holistic view, you see the intangibles of what the state of a piece of equipment is by being able to really take a sharp look at it. And it's extremely useful for measuring distances, measuring what could be, the size of a feature on some piece of equipment, and that's the type of reason why we are looking at getting some new HD cameras in some of the subsequent EVAs in advance of the U.S. commercial vehicle docking events, so that we can use those to judge distances and aid the crew, both on the U.S. commercial vehicle and on the space station side, in being able to complete a successful and safe docking process.
So ultimately makes things safer, makes things easier, makes things a little bit more reliable, I guess, for operations.
Absolutely. And it is nice that it also puts out some pretty pictures, too.
Great benefit there. So how about the wireless communication aspect of this? So we're adding an extra antenna, extending the reach. What's the history of that project? How have we been sort of upgrading the external wireless capability of station?
Sure. The way we get work done on the inside of station is with laptops hooked into a network. We have core systems that are designed to keep the station running, and that's got its own dedicated system. But as far as how we get a lot of our science down from station, it all goes on the joint station LAN, as we call it. Well, in addition to what is allowing those laptops to work inside a station, we have found that there is benefit to having that Wi-Fi outside a station. So there's a payload coming up on SpaceX 15 called EcoStress. It's going to go out on the Jeff, and it is going to look at, it's an agricultural examination payload, so it's going to look at the Earth going by, take a look at what is happening to plants that are growing, judging their temperatures and seeing what that means for the overall health of the environment. That type of information, you could send that through the normal station command and data handling system. However, with the high bit rates that we're using now with payloads, the sheer amount of information, it is useful to have an adaptable system like Wi-Fi to put it onto our standard station LAN and get it down to the scientists who can use that data to make the world a little bit better.
Wonderful. And they got a great view of the Earth to do all of that.
Absolutely.
So I think we're going to go back to the social media using the hashtag AskNASA.
Yes, from Twitter. How do you stop the light and UV rays from the sun from damaging the astronaut's eyes?
It's 100% UV protection on the visor itself. So there's a couple of layers. There's the bubble and then the visor assembly. The visor assembly does stop 100% of the UV.
And do the astronauts ever feel the temperature of the handrails or any sort of temperature from hot and cold through their suits?
I've talked to several of them, not really from the handrail, but if they're idle in a dark position, they'll start feeling the cold. And if they're out in the sun for a while, they'll start feeling the warmth. So it's not necessarily from just touching the handrail itself, but being idle or not moving. As I say, your hands are your primary work area. So as long as you keep moving and keep working, a lot of crew members will monitor their heat by their workload. If they're getting hot, they slow down. If they're getting cold, they speed up a little bit in their work profile.
So Grant, kind of expand on that. What is the preparations to get the suits ready to go outside, both in terms of the technology of the suit, but then also the astronauts inside? I know they have to do some sort of exercise, but what's the reason for that?
The exercise is part of our pre-breathe protocol. So as soon as the crew gets in the suit, they're breathing pure O2 environment, and we need to denitrogen, take the nitrogen out of our body, keep from getting the bends. So we do that breathing pure O2. By doing light exercise, it helps stimulate the nitrogen and get it out of the system so we can purge it out of the suit. So we're not accustomed to getting the bends, or we haven't got the bends yet. So.
That's right. And now that we have three new crew members, actually, Oleg Artemiev as well as Drew Foysel and Ricky Arnold, that are going to be going out. So right now they are actually, I guess through the week, they're preparing their suits. So what are some of those tasks?
Actually, they're more preparing their tools.
Really?
So the suits, we've gotten a lot of that done by Maker and Nemo up there. So we were able to start the suits a little bit earlier and gather some of the tools. And Ricky and Drew are getting out there and finalizing it. So we did have a little bit of activity today to fill their LCVG, which is their liquid ventilation cooling garment that flows the water over their body to keep them cool while they're working. But to do that, we've just started flowing water. And so they're prepping some of the suits, but most of it, the resize, the preparations for keeping it all clean and healthy have been done prior to them getting there. So we start that about 3 weeks out.
So how about the procedures? You said you were developing them since October and kind of fine-tuning them. So how is that process?
Procedures are almost done. I'll say almost done. Let me knock on wood, because we have one more rev today. Since the crew has really started looking at it and getting on board, with just 6 days between when they get on board and going out EV, they have some last comments that we're incorporating into the procedure just for their nuances and the way they want to do it, as opposed to the way we generically planned it. So we're making those last-minute tweaks, and it's really nice because they're small pin and inks to the procedures, and we'll be ready.
You know, and that's one of those things that reminds me of just the wonder of human exploration, is because the crew, we have a mock-up in the pool where we say, you know, we think this is the best way to go to get to this spot. Crew gets on orbit, takes a look, they open up the window, look for themselves, and they say, you know, that would work, but it would be better, I think, if we went this way. And those are the types of changes that Grant's incorporating into those procedures. It is absolutely crucial to have the human with all the human senses looking at the environment that they're in and making those decisions to inform us on the ground of what the best way to do things. It's a great collaborative effort.
So how are you helping them from the ground? Do you have a team of EVA experts that are sort of looking at these procedures?
Absolutely. Yeah. And you know, Grant's part of that, and Grant's whole team is part of that, but there's also the vehicle systems that are running underneath this EVA. So we got to look at make sure that all the the solar arrays are in the right positions for the EVA. We got to make sure that all the cameras that they're working on are turned off, that are safe. So it is a huge team effort. You know, we run simulations on the ground where we're sitting in a room that's just like mission control. We have people that are doing the job of the crew members over in a building, in a training building, and those events are absolutely invaluable for allowing the team to come up with new questions to ask about what's the best and safest way to do this. To put yourself in that environment really allows you to think about it from a different perspective, and it's a big team effort.
And part of that team is actually some of the crew members on the inside. And Kenny, I know part of the task is for crew members inside to actually be controlling the robotic arm and having a crew member at the end to do that. But then on top of that, they have to review procedures for just a couple days later on April 2nd to capture the SpaceX Dragon. So how is that working together to make sure these operations go smoothly back to back?
It's quite the choreography. I mean, again, there's usually a planning process that starts weeks out as you start to see all the things coming down the pike and so there's, as I said, a bit of a choreography to make sure that we're continuing to make progress on being ready for next Monday, Tuesday, and Wednesday, but at the same time making sure that we don't lose focus on trying to do this critical EVA. So anyway, it's something when you only have 2 crew members on board, like 2 USOS crew members like we've had for the last month, it makes that a little more of a challenge. But that wasn't a surprise to us, so we were able to work through our normal priority type of task and make sure that we were doing the things we needed to do to keep to keep these different areas of focus in sight, so that we didn't lose anything and didn't see anything drop off the plate. So anyway, as Grant said, we started doing a little bit of prep work prior to Drew and Ricky's arrival. So it's not like they opened the hatch and said, okay, now I got to go do all this stuff to get my suit ready. A lot of that stuff was done up front, and again, that's all. That process for getting ready for an EVA really stretches out a couple of weeks ahead of the EVA. Certain things that you do along the way, and we're always populating other things in and around that, things that have to be done, whether it be science or preparing for a vehicle just afterwards, or other maintenance activities. So it's not like we stop the other things we're doing. We just have to figure out how to integrate them all together, and the team does a fantastic job of working through the priorities and understanding the templates and what has to go when to allow us to be able to get everything done. So
it's a really busy time, right? You got a crew launch that just came up last week. Now we have an EVA, then we have a cargo mission going up. But I guess one of the biggest benefits is now we have extra crew members on board to help us with some of the. So what are some of the biggest benefits of having the extra crew now on board for these next few months?
Well, in general, when you get in a time frame like this, as I explained earlier, where you have 2 cargo vehicles coming up, plus 3 EVAs in this time frame, to think about doing that with 3 people, the reality is that volume of work just can't be done by 3 people, and specifically with only 2 on the USOS. But when you look at some of the other things that we can't physically do or can't do because our rules don't allow us, and when we have 3 people, we do have some things that we just can't do. EVAs are much more difficult when we only have 3 crew members on board station, and we've done it before, but it takes a very integrated effort with our Russian colleagues in order to make that happen. So having a complement of 3 or 4 USOS crew on board gives us that flexibility for scheduling and being able to put them where we need based on all the other activities we have going on the USOS segment. So there's a lot of flexibility that we enable by having the extra crew members on board. So just in terms of getting the work done and being able to plan our own work as we see fit.
I'm sure it's appreciated both here, but then also internationally, right?
Absolutely,
yeah.
Absolutely.
So I guess we'll take it back to social media using the hashtag AskNASA.
Yes, Darren on Twitter would like to, one more time, if you could explain the hardware on the table. They tuned in and would like to know what that is.
Okay, well, I'll take this one. So this is a shunt jumper. It's a part of the ammonia system. So we have the ammonia loops that eventually cool the station. So the heat from station operations, the crew themselves, all the systems goes into a water loop inside of the vehicle. That water goes through a heat exchanger to an ammonia loop, because ammonia has extremely valuable thermal properties and can take on a lot of heat, and we send that ammonia out to a radiator, and that's what cools it off, because we can't dump our heat into there's no air around us that we can radiate into, so we lose all of our heat through radiation to the space environment. This particular jumper, it's got 2 ends here, and originally, when it was in its first incarnation, it was just there to complete the circuit, because whenever you have a supply, you need to have a return. Ammonia's got to go somewhere. So you plug this into one side, plug it into the other, and then it would allow the fluid to do a loop before the Node 2 module arrived on board station. Now, we disconnected it and we stowed it back in about 2007, because we now had Node 2 available or about to arrive. So this has just been sitting there up on station, wire tied to inside of the truss. Crew member put it there on an EVA, I think EVA 10 or 11. And so there it was to sit until we realized that we could make the next EVA, EVA 50, a little bit more efficient by using this as a place to store some ammonia while we were taking away some of the expansion capability that ammonia needs to survive thermal cycles. Ammonia is bottled up, it gets warm, it's going to want to go somewhere, it's going to want to expand. This is that expansion that we can use rather than the original plan, which was to vent out that ammonia. It was only 1 pound, it wasn't going to be a big deal to vent it out, but there are some time savings if you are able to use this jumper. So we're going to go make sure we can access it, get it in place so that US EVA 50 is going to start just a little bit ahead of the curve. And we appreciate the 49 team for getting this for us.
We have one more about astronaut training. Other than the training underwater with the MBL? Is there any other type of training that they do to prepare for a spacewalk?
The spacewalk, yes, we definitely teach them on the system side. So most of our system is classroom training or simulator training. So we teach them how to use the suit, work on the suit, and that part of it, as well as training in the water. And of course, every water run, to keep from going out for just 6 hours in the pool, we also have a 2-hour event prior to that, so they can get hands on the equipment prior to going into the pool where they're going to be working on it. So we have systems and task side training. So.
Wonderful. Okay. I guess we'll wrap up our coverage today. I just wanted to thank you guys for coming on and explaining all the intricate details, fielding questions here in the room, social media, but then also my personal curiosity, so I appreciate that. So again, the EVA is going to be happening in 2 days on March 29th. We're going to start our coverage at 5:30 a.m. Central Time, so you can tune into NASA TV, or you can go to our website, nasa.gov/NTV. We'll also be streaming on Facebook Live, and you can tune in and provide comments that may be answered throughout the EVA, so make sure you tune in there. Otherwise, if you have more questions about the EVA or spacewalks or what's going to be happening on board the International Space Station, go to nasa.gov/ISS. Again, we're looking to head out the door at 7:10 a.m. Central Time on Thursday. So I'll thank everyone in the room for fielding their questions, and best of luck to the team here for a successful EVA in 2 days. Thanks a lot, guys.
Thank you.